This is CPM Precalculus Chapter 2, Number 30. So Brian has the following sums to find. Okay, he has this whole list. This ... means that it continues on every sum in between. And finally, so 1 plus 3, we know is 4. 1 plus 3 plus 5. 4 plus 5 is 9. 1 plus 3 plus 5 plus 7. So 9 plus 7 is 16, right? And so on through this. So we want to figure out this sum and all the ones in between, but finding a shortcut so that we will not have to add them all by hand. So we don't want to go and add 1, 3, 5, 7, okay, and so forth through 101. So what you have to do is kind of look for a pattern. And I would offer the suggestion that instead of watching this video, you kind of look for the pattern yourself, because it's kind of a pattern that you have to kind of think about and see if you can find it. Because if you just look at the solution, it might not allow you to really think about the pattern, because when you do find it, it's kind of cool. Okay, so I'm going to keep going, but you can go ahead and stop and think about it longer if you would like. So first we have 1 plus 3 is 4, 1 plus 3 plus 5 is 9, 1 plus 3 plus 5 plus 7 is 16, and do we see a pattern? Well, I'm seeing that we're adding odd numbers, right? 1, 3, 5, 1, 3, 5, 7. What's the next set going to be? 1 plus 3 plus 5 plus 7 plus 9. And what's that sum? Well, 1 plus 3 plus 5 plus 7 is 16, plus 9 is 25, right? What's the next going to be? It's 1 plus 3 plus 5 plus 7 plus 9 plus the next odd number. Okay, that's going to be 25 plus 11 is 36. And we keep going until we get to the odd number being 101. So in between here is going to be 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13, ... right? Until we get to 101. So before we get there, do we see any pattern here? Well, I see something, right? I see the sum is 4, 9, 16, 25, 36, and so on. Do you see any pattern of 4, 9, 16, right? This is not 1.6. This is 16. 25 and 36. Well, these are all perfect squares, right? 4 is equal to 2 squared. 9 is equal to 3 squared. 16 is equal to 4 squared. 25 is 5 squared. 36 is 6 squared. The next one I bet is going to be 7 squared, 8 squared, 9 squared, all the way through this one is going to be something squared, right? So that's the first part of the pattern that I see. The second part is, well, what is going to be squared here, right? What is going to be squared? Well, if you kind of look at this, you could think of, well, this is how many terms? 2 terms. So that's where we get to 2. That's one way of thinking about it. 1, 2, 3 terms. That's how we get to 3, right? 1, 2, 3, 4 terms. That's how we get 4. 1, 2, 3, 4, 5 terms. That's how we get 5. 1, 2, 3, 4, 5, 6 terms. That's how we get 6. This one, 1, 2, 3, 4, 5, 6, 7. Well, how many is that? So is there a way we can find this without knowing how many terms are in between there? Okay, so if I knew that number, I could just say the number of terms, right, being added squared, right? That's going to be the pattern so far. Well, is there any other pattern that I see to help me get this? Right? Well, let's go ahead and look at this a little more and look at numbers. Well, 1 plus 3 is 4. And 4 is the same as, like, well, if we divide 4 by 2 and squared, that's the same as 2 squared, right, which is 4. Okay, well, let me go ahead and see, well, what divided by 2 is equal to 3? Well, 6 divided by 2 squared is equal to 3 squared is equal to 9. What divided by 2 is equal to our 4 here? Well, 8 divided by 2 squared is equal to 4 squared, right, is equal to 16. And I'm just kind of looking at patterns. Here, well, what divided by 2 is 5? 10 divided by 2 squared is 5 squared is 25. What divided by 2 is going to be 6? Well, 12 divided by 2 times or squared is equal to 6 squared is equal to 36. Okay, so that's a little bit helpful. And if you look, 1 plus 3 is 4, right? Let me use a different color. 1 plus 3 is equal to 4. What's equal to 6 here? Well, if you just take the first and last term, 1 plus 5 is 6, right? Well, what do you see here? 1 plus 7 is 8. Okay. 1 plus 9 is 10. 1 plus 11 is 12. And so you just see that if you keep doing that, you're going to get all the numbers. So what's 1 plus 101, right? Well, 1 plus 101 is 102 divided by 2 and squared, right? So 102 divided by 2, you can use your calculator, that's just 51 squared, okay? So that is going to be the sum. And every sum in between it is basically going to be 4 squared, right? The shortcut is that the sums are 4 squared, then, oops, not 4 squared, excuse me. The sums are 2 squared equals to 4, 3 squared equals to 9, 4 squared equals to 16, 5 squared equals to 25, 6 squared equals to 36, and so on until we get to 51 squared, and that's the last one. And what's that equal to? We can put in your calculator, 51 squared, and that's equal to 2,601. 2,601. Okay? And so this is the pattern, and we do not need to do any like adding by hand really. And we get all of the numbers that he wants to find the sum of. Okay? So that's the pattern and the shortcut to find. And if you're able to do all of it or parts of it on your own, great job. And this ends helping out Brian find the following sums in CPM Precalculus Chapter 2, number 30.